ሰላም ተማሪዎች እንደምን አላችሁ? እኔው ነኝ የአስረኛ ክፍል የፊዚክስ መምህራችሁ ከሉሲ ብሪጅ አካዳሚ። ዛሬ የምናየው አምስተኛውን ሴክሽን ወይም ደግሞ የመጨረሻውን ሴክሽን ይሆናል። ቬክተር ሪዞሉሽን። what is vector resolution? እናም የተለያዩ መሰረታዊ የምንላቸው ነጥቦች አብረን የምናየው ይሆናል ማለት ነው። ወደ ትምህርታችን ከመቀጠላችን በፊት ግን እንደ ሁሉ ጊዜው lucybridgeacademy.com ዌብሳይታችን ላይ በመግባት የተለያዩ ሾርት ኖቶች፣ ጥያቄዎች እንዲሁም ከ5 በላይ ቋንቋ መረዳት የሚችል የኤአይ መተግበሪያ ማግኘት ይችላሉ። በተጨማሪም የዩቲዩብ ቻናላችንን ሰብስክራይብ እያደረጋችሁ እናም የቴሌግራም ቻናላችንን ጆይን እያደረጋችሁ ሐሳብ አስተያየታችሁን እንድትሰጡን ስንል እንጠይቃለን። እናመሰግናለን። ወደ ትምህርታችን ኦኬ። በዚህ ሴክሽን የምናየው መሰረታዊ ነጥብ የምንለው ቬክተር ሪዞሉሽን ማለት ምን ማለት ነው? what is meant by vector resolution? what we meant by vector resolution, and that of the introductory part of the vector resolution, we call that resolution meant by simply splitting one vector in two different components. In this case, without a single vector, which can be broken into what? Two perpendicular components. Either it is the horizontal and vertical component. We call it what? The resolved vector. We have what? A vector A, which is split into two components, which is what? The AY and AX, which is what we call it is resolution. Then in that of the components, when we add vertically, that's the vectors which can be given having that of the original vector or the resultant vector A, that they combined and gives what? The same property as the resultant. In this case, this method is simply, we call it what? Resolving. So by having this, the resolution happens without the resolution of vector here, a vector A, which is converted to what? Converted to two components, AX and what? AY. Then AX, which is having that of the trigonometric property without of the vector A, which looks like a hypotenuse. When we resolve it, that's the two components, AX and AY, that's A makes an angle theta. The resultant vector or the original vector, which makes what? An angle theta. So by having this, by that of the trigonometric property, the trig property, using trig property, that we have what? The value of AX and AY, which result is AX, which equals to what? Which equals to A cos theta, which is the adjacent side. AX is what? The adjacent side for an angle theta on that of the original vector, whereas AY, which is the opposite vector, where AY, which is the result is what? A sin theta, which is an opposite vector. In that of the trig property, the opposite vector or the opposite side, which is given by what? A sin theta. So by having this, we have what? A sin theta and A cos theta without what? The splitted vector A. So in this case, this method, what we call it is what? Resolution. So in such case, without the graphical method of vector resolution, that we draw a vector scale, having that of the vector scale, by scaling the magnitude and direction of the vector. Basically, the magnitude having that of what? For different vector, like that force, velocity, acceleration, and any other, which we have to scale it. Either the direction is depending on that of what? Depending on that of the dimension. Either it is 1 dimension, 2 dimension, or 3 dimension. That is X x-axis, y-axis, or z-axis, or from that of what? X, Y, z-axis. That we have to join it head to tail. Head to tail. So in this case, without the vector resolution, we have to drop it perpendicular line. The perpendicular line on that of the resolved vector, which is forms what? The vector tip to that of the x-axis and the y-axis, which has a component intersection. That is what we call it, that of the resolved vector A, that we just make it ax here, and ay here, which is joined what? Head to tail. To head. Okay, here it is. The first vector x from that of the tail of A, which is joined to that of the tail of what? Ay. The tail of Ay. Here it is, tail of Ay. Then after Ay, which joined with that of what? The head of A. The head of A. This is what we call it is what? How we can draw the vectors in scale diagram. A scale diagram. Or the vector diagram. This is what we call it is a vector diagram. So, as we discussed earlier, that the horizontal components of the trigonometric value of the splitted vectors, ax and ay, which equals to what? A, which is the same as a cos theta, which is the adjacent side of the vector, and ay, which is the same as what? A sine theta, which is the opposite side vector of the splitted vector. Then we deliver this having that of what? The definition of the sine and the cosine using that of the angle theta. Then having this, the position of the vector, either that of in the northeast, either that of the northwest, either that of southeast, or what? Southwest. Or simply on that of the horizontal and vertical axis. If a vector A, which is in the horizontal axis, which is the same as what? Ax only. Here, for a clear definition, here, if a vector A in the horizontal, only in the horizontal, then it has what? Ax, which is the same as the vector A, the splitted vector. But here ay results what? 0. No vertical component for that of the vector A, which is what? To the horizontal. Whereas the vector A, which is to the vertical. Thus here we have what? A, which is the same as what? Ay. That we have again A to the x for that of the vector to the vertical, which is what? 0. No horizontal component. So in such way, you can understand how to resolve a vector. In that of a given vector, which is found only to the horizontal, a given vector A, which is found only to the horizontal vector, and the vertical vector, that you have to remind that, or you have to think about that, that's the vector which exists only to the x-axis. To the horizontal, only to the x-axis. To the vertical, only to the y-axis. Where in that of the horizontal vector, that there is no y component. In the vertical vector, there is no x component. So you have to mind this. In that of a given xy plane. Okay? If it is in the northeast, if A is found in the northeast, you have what? Both x and what? Y component. In this we have ax and a y. Ax and a y. A y to the vertical and ax to the horizontal. You have to think this thing on that of what? On that of the vector resolution. Now let's do a brief example for that of this vector resolution and how to calculate the magnitude and the direction of the vector. And we can have by having that of its direction, we can have the magnitude of each component. Let's see, for example, here a motorist undergoes a displacement of 215 kilometers due the direction of 30 degree north of east. Resolve this displacement into the component method. In that of this here, in our solution, the motorist which travels the displacement of what? 215 kilometers to the northeast here. So we have to resolve it. To the x-axis here, s to the x, and what? Here, s to the y. So by having this in that of the resolution 1, s to the x, which result is what? S cos theta, where theta is what? At 30 degree. So put the value in here to that of the horizontal component, sx, which is the same as what? The value s is 215 kilometer, cos the angle theta, which is 30 degree, having that of the value 250 kilometer, with that of cos theta, which is root 3 over 2, having a trigonometric values. Here, the trigonometric value cos 30 degree, which equals to what? Root 3 over 2, whereas sine 30 degree, which is the same as what? 1 over 2. Putting this value here, we have what? By 2, 1 by 2, 125. Here it is 125 root 3 kilometer. To what? East. Here it is. The vector resolved to the x-axis. Whereas to the y-axis, the second one, to the y-axis, which results is sy, which is the same as what? S sine theta, which results is substituting the value here, 250 kilometer times sine 30 degree. Then 250 kilometer times 1 over 2, which is the result is what? 125 kilometer due north. Okay? You can split the value here. This direction, which indicates what? The northeast. With that of the horizontal direction, it is what? East. And the vertical direction, which is north. By having this, you have a magnitude and direction of the splitted vector. The resolved vector. So this is what we call it is how to resolve a vector, one vector into two different components. Or you can split one vector into two different components. In this case, without the resolution, the basic thing that we have here, using that of the right angle triangle theorem, the vector resolved. Here, which makes what? An angle of 90 degree. Then we use what? A right angle triangle theorem with that of the vector, the original vector A. Then having that of AY and what? AX. Having that of AY and AX, the magnitude that we determine using that of what? Using that of the Pythagoras theorem. The Pythagoras theorem, the magnitude of the original vector or the resultant vector, which result is what? Under the root of ax squared plus bx squared, or the right angle triangle theorem. And the direction which is determined having that of what? By having that of the tan theorem or the tan angle formula. So by having this theta which is equals to, or tan theta which equals to ay over x, that is opposites over what? Adjacent. Then by imply that the angle or the direction which is determined by having that of what? Tan inverse of ay over ax. This is what we call it is the simplest form of calculating the magnitude and direction of a given vectors. So let's see Another example. Let's see another example, which we have to determine having that of the magnitude and direction of the original vector or the resultant vector. By having this here, for example, the displacement, which is found having that of what? Having that of 3 kilometers to east and 2 kilometers to north. 2 kilometers to north. So by having this, the resultant S, the resultant displacement, that the body or the boy moves 3 kilometers due east and 2 kilometers due north is given us. The magnitude is given us here in our solution. 1, the magnitude of the boy's displacement, which result is what? Under the root of the horizontal square, the horizontal displacement square, plus what? The vertical displacement square. So by having this, the magnitude of the displacement, the result is what? 3 kilometer square plus 2 kilometer square. This result is under the root of 9 plus 4. 9 plus 4. Then this result is 13 under the root of 13 kilometer. Okay? This 30 kilometer under the root of 30 kilometer, that we won't take out from that of under root, that we put as it is. Or you can use the square root table, or having that of the scientific calculators. Scientific calculators or a calculator, you can manage to have what? The result. We can manage to have the result. It's approximately 3.4545 kilometer. 3.45 kilometer. And with that of the direction, for the second is the direction theta, which equals what? Tan inverse of what? The vertical to the horizontal. The horizontal. The vertical to the horizontal. Then result is tan inverse of the vertical, which is what? The vertical, which is 2, and the horizontal, which is 3, then which is equals to tan inverse of 2 over 3 by having that of the trigonometric table. The tan inverse of 2 over 3, tan inverse of 2 over 3, tan inverse of 0.0.667, 667 approximately. 0.6667 or 0.67. Then results a given value. You can check on that of your trigonometric table. From that of your trigonometric table, 0.66 how much? Then you have what? The angle or the direction of the resultant vector, root 13 kilometer, root 13 kilometer. So in this case, on the last lesson that we discussed is about what is a basic summary of what? The vector resolution concept. Without of resolving or resolution meant by what? Simply splitting one vector in two different components. A vector can be resolved either in that of the vertical or the horizontal components. Without of the combined effect of the component, which results what? The original vector. Which is the same as what? The original vector. The combined form of the vector which have a resultant vector A has a combination of what? The components of the two vectors. Then that resolution which helps to simplify what? Very complex problems and use basic trigonometric properties. And also use to identify what? Identify the real life problems, like that of moving on steps or moving on mountains. Okay, walking on the mountains. That we use what? The slope of the mountain or the slope of the steps. By having this, we understand that how we can resolve the vector component, having that of the vertical and the horizontal component. Okay. On the next video, we will discuss about the basic things about what? The questions regarding that of the resolution of vector including the review question on 1.5 lesson. On 1.5 lesson, what we call it is the resolution of vector. Okay, resolution of vector. At the end of this session, you will be able to understand how to resolve vectors and also how to calculate different problems on regarding that of what vectors. እንደ ሁል ጊዜው ግን መርሳት የሌለባችሁ lucybridgeacademy.com በመግባት የተለያዩ ሾርት ኖቶች፣ ጥያቄዎች እንዲሁም ከ5 በላይ ቋንቋን መረዳት የሚችል የኤአይ መተግበሪያ ፕላትፎርምን የዩቲዩብ ቻናላችን ሰብስክራይብ እያደረጋችሁ ቴሌግራም ቻናላችን ጆይን እያደረጋችሁ ሐሳብ አስተያየታችሁን ትሰጡን ዘንድ እንጠይቃለን። እናመሰግናለን።